Thank you for the introduction, Peter. So, welcome to my presentation on declarative thinking in SQL, its teaching and its unused potential. My name is Günter Burgstaller, and I'm a teacher at the Technical College in Austria. So what I'm going to talk about, since it's also about teaching, I will say a few words about the context where the teaching takes place. Then I will talk about teaching SQL as a declarative language. Then we'll look at some case studies. We will compare declarative SQL code versus code written in so-called procedural extensions. And finally, we will talk about the findings. So I'm a teacher at, as I mentioned, at the Technical College in Austria, and the Austrian technical college system is special. It's HTL is the German abbreviation. So our students are aged from 14 to 19 years. And they get 5 years of practical and theoretical training in engineering. They have about 34 lessons per week. And from third grade on, also 72 of those lessons are taught in English in a technical subject. They also need to do 8 weeks of mandatory summer internships in some IT company, which could also be abroad, so in any European Union country. They have their final exams includes diploma thesis, and when they graduate, they are sought after engineers and they can work in virtually any IT profession. And also students that drop out are also in high demand. And the graduates, well, we have a dropout rate of 50%. Yes, but most of those who leave after so 1/3 leaves after the first year. And it has to do with the Austrian school system, but I won't go into details here. And the graduates are also eligible for university, and it's accepted or recognized as the lowest tertiary level in the European Union. So our graduates count as academics. So you're probably familiar where Austria is located in Europe, and is it okay? And here's Vienna, the capital. Here is just outside where I live, in the town of Mödling. And the school is in Wiener Neustadt, which is about maybe 50 kilometers to the south of Vienna. This is what the school looks like. And we have 4 departments, the electrical engineering department, mechanical engineering, construction engineering, and the department where I am teaching, the informatics department, which is in the newest wing of the building, this blue building here. What do the students in the informatics branch learn? Of course, they have general subjects like German, English, maths, and so on. And well, it might look like a wish list what employers would expect from graduates, but actually this is taught over the 5 years in the curriculum. So it's computer architecture and operating systems, programming and software engineering, databases and information systems, which I mainly teach, then network systems and cybersecurity, web programming and mobile computing, data science and artificial intelligence, which is actually a new subject, which I will teach next year. And they also have business economics and management, and also system planning and project development. So what formal languages do students learn? I'm talking about 2 subjects, database and information systems, which I teach, and programming and software engineering. And in the first grade, they start with Python in programming, And actually, the subject is called databases, but they have no databases. In the first year, it's only Office software. So you could count Excel as a declarative technology. So I have it in parentheses here. Then second year is C++ and a bit more of declarative topics like HTML and SQL in parentheses again, because it's only used very basically to connect, for instance, to connect from PHP to a database, from a web page, show something from a database, but not in detail. Then in the third grade, they learn in programming Java. And here we have a focus on declarative technologies. So we have SQL in detail, eBNF to describe SQL syntax, entity relationship diagrams for data models, and also the whole XML toolchain. In the fourth grade, they have C# and JavaScript, and also SQL, but it's only, how to say, there are some details added, but we build on what they learned in third grade. And what is new is procedural extension, TSQL for Microsoft SQL Server. And in fifth grade, they have again Java and C#. We build again on SQL, and we use Oracle databases. So we have as a procedural language PL/SQL, and they also have to write their diploma thesis in LaTeX, which means, which is also declarative technology. So I've put it here, but in parentheses. So when I teach, well, I have to apologize to show this. Not long before the lunch break, I hope you are not hungry, but when I teach declarative technologies in third grade, I have to explain to my students what declarative is. Of course, this is a simplistic explanation, but it's very easy to say that you want Wiener Schnitzel with potatoes and rice and a slice of lemon. And the difficult part is to prepare it. So whose problem is it to prepare it? Of course, the problem of the cook. On the other hand, if we look at procedural Wiener Schnitzel, it gets very complicated. So the list of ingredients already is a problem. Then all the terminology, we need to beat the cutlets, and we need to beat eggs, and even gets dangerous because we need, there is a hot fat that hisses and bubbles involved. And when we are finished with that, we only have the schnitzel and not the sides. So it's a lot easier, the declarative way. So what are the topics? I will later come up with maybe a better explanation of what declarative is. But for the beginning, this will, you will use that. So what are the declarative topics in third grade, and how much time do I have for that, for teaching that? So first thing is eBNF to describe SQL syntax. And we use that in exercises. And we are using the website of Günter Rademacher. Maybe some of you will know it, where you, where you can create syntax diagrams from descriptions in eBNF. Then we have 24 weeks where we work with SQL in detail, DDL commands to create tables, then to insert data. And most of the time we spend with querying the data, of course, the select statement. And we also use basic transactions. And after that, we spent 10 weeks on designing data models with ERDs. And since we know already how to use SQL, we can implement the data models immediately. Most books or curriculums do it the other way around. They do data modeling first and then SQL. But we found out it's a better idea to do it the other way. Teach SQL first and then do data modeling. And we have, unfortunately, only 6 weeks to do the whole XML tool chain, and the focus is on validation and xquery. In the year after that, it works well. They have no other way of, but they only know about SQL, and they only can use it declaratively. But since they had a lot or most of the training was about procedural programming, when we start learning in the next year about procedural extensions like transact SQL in 4th grade, they fall back into procedural thinking. So they relapse into the loop obsession because all solutions somehow involve loops. And of course, when I introduce procedural extensions, I have to explain why do we need procedural extensions. And a retired colleague had 2 examples that, so according to him, proved that because we cannot solve them declaratively, we have to use procedural extensions, or there have to be procedural extensions. When I started teaching, well, I taught or I told the students the same, but it dawned on me at some point that there has to be a declarative solution for the problems. So we'll talk about the problems that he suggested soon. Or are there other reasons why we need procedural extensions? And the final question, do we need procedural extensions at all? So here is one of the challenges that he had. So we have a table of parts, and the task is a bit contrived. We have to increase every second price by 5% in the order of the part ID. So T2 would be increased, T4, and so on. And allegedly, this can only be solved with procedural extension. Well, I give this as a task to the students to do it declaratively. And of course, it must also work when there are gaps. For instance, if T2 is missing, then T3 is the first one that has to be raised. So some think that you can interpret this as a string, take the number, and then look if it's odd or even, and then you have solved the problem. But it must also work when there are only, for instance, odd numbers, T1, T3, T5, and so on. So let me see. Here is actual bad procedural solutions. When I give this as a homework, then this is what solutions usually look like. So they use cursors, which are very slow and inefficient. They are so inefficient that RDBMS vendors are considering to remove cursors from the systems. But this is what I meant by falling back to procedural thinking. And cursors also have error prone because they need a lot of housekeeping. You need to open the cursor, you need to fetch data or look if there is data there, then you have to test if there is any data. And here's the solution for skipping every second row by fetching it twice. And you always have the risk of infinite loops when you use this kind of code. So what would a declarative solution look like? And I have it here. The only thing is what you need a second column that tells us what I use here is a subselect in the select list. You can do it for many years now. So it was the last spot where subselects were allowed in SQL. And the trick is only to count all parts that are smaller or equal than my part ID. So if we, I'm using SQLite for this, and as we can see, we get, so the order column is the result of this subselect here. So now we know, or we have a means of determining which row we are. And we can now use that for updating the row. I'm doing this in a transaction, not to not actually change the data. And here is the update that uses this order in the where clause, and I calculate the modulus, modulo 2, and when it's 0, then it's the second, and it will be updated. So here we have it before the change, and here we can see every second is updated. And to see that it works in the case where T2 is missing, I remove T2, and since there's a foreign key, I turn the checking of foreign keys off, which is the quickest way of showing you. So now, did I save it? I did. Why is T2 still there? Foreign key. Foreign keys. Okay, so I don't know why it doesn't work when I put it here. So we see T2 is missing now, and it still works. So that was rather an easy one. So let's look at another challenge. So here, same table, and the other challenge that my colleague had, where he claimed that it can only be done procedurally, is increase all prices by 5% till the average of the prices is smaller than 16, or while it's smaller than 16, increase all prices by 5%. If you think about it, there seems to be no easy solution in SQL. There is one, but I have another more general solution. So we have another declarative. So this is what procedural solution would look like. You have a while loop that checks if the price is smaller than 16. If it is, we do an update on all part prices by 5%. And well, I will show you. And this time it's on SQL server. So here it is. The initial average price is 15.1 something, and then we increase it. We have 16.72. So what could be a declarative way? Well, another declarative language to the rescue. If we want, if we have an equation and we say the average part price, how often do we have to raise it by 5% to get exactly 16? We can transform the equation because we interpret by the average part price. And so we apply the logarithm to get n times log 1.05. Of course, we have to apply the logarithm to the right-hand side as well. And then we are left. What is? Okay. We divide by the logarithm 1.5, and we have n. So the students, I would be very happy if students would come up with a solution like this, because they have the knowledge. And but it's often very hard to apply knowledge from different subjects to a problem. So it so usually they don't find this solution, but we have not checked yet if it works. So here would be the update. So we increase all part prices by the power of 1.5. And here we have in the subselect the value from the equation or the expression that calculates the n. And since we have to do it in integers, so we have to use the ceiling function to get the next bigger integer. So let's have a look if it works. But I will have another window here. And here is the solution. So here we only compute the value. And here we use the value to do the update. So if we have a look at it. Yeah, sorry, I don't know how to change it because I will only use the mouse pointer. Here we can see, unfortunately, we don't get the same result. So did we have some mistake in the math? No, the problem is SQL. It wouldn't be SQL if it would work as expected. The problem is in a power function implementation of SQL Server, because it does some unexpected rounding because we only supplied 2 digits. It would work in SQLite. If we had done the same, selecting SQLite, it would be correct. But since SQL is an ISO standard, but it's used by the vendors more as a recommendation than as a standard. So one fix would be this: simply, you could also cast it to a different number type. And now we see that we get the same solution as the procedural solution was. But you always have surprises when you take one SQL and use it in another system. So this is the about warts and wrinkles in the SQL, and it was due to the power function. You're lucky if you have a power function at that. So the standard does not say what functions you need to have in, or if it says, then the vendors don't care. So by the way, what RDBMS do we use or have we used? Because we experimented a lot. We use SQLite. We use Microsoft SQL Server Express, Oracle Database Server Express Edition, and we used MySQL and PostgreSQL. And why do we use the systems? One is employability. So we think that SQL Server and database, Oracle database is still big there in the market, and if students know how to work with it, they have better chances to get a job. Then adherence to the SQL ISO standard, but this is a bit of unnecessary, because in any system you can find blunders where they I will talk about the standard a little bit later. So, for instance, we went away from MySQL because my colleague thought that it does not stick to the standard. But if you look, you can look at any system, and you always find issues where it's odd. And we also use the system because of the availability and quality of documentation. For instance, database architecture, Oracle has very good documentation, and SQLite has very good documentation. And we also decide, because of the ease of use, if you use free software, you have no troubles with licensing. Then here is another task that I give to my students, which is the sieve of Eratosthenes. It should have been invented by Plato, which would be easier to pronounce. Unfortunately, he hasn't. So the task is you read the Wikipedia article on that algorithm. So it's about prime numbers, which you probably know. Then fill a table called primes with the values from 2 to 2000, and write code that removes all non-primes from the table by using this sieve algorithm. Optimizations should be considered. And then the students should record the timings for their program for 1,000, 10,000, and so on, up till 1 million numbers. And then they should write a query that counts the number of primes that are left after applying the sieve, and also the number of palindromic primes. For instance, 13931 would be a palindromic prime, so it's the same read backwards. And that should be the output of the program for 100,000. So this is my declarative implementation, and it takes less than 2 seconds. And for 1 million, it's about 10 seconds. So I think it's a nice example, because for me, it's seems to be easy to translate the algorithm into SQL. So what do you need to do? You delete from the table primes, where you have initially all numbers, all those who are divisible by 2. And here is another example of the SQL standard, because you cannot use the % in Oracle for modulo. You need to use the mod function. So this removes all even numbers from the table. Then the next step would be to find the next prime, which is the smallest number that is bigger than 2. So the prime we used in this round. And then you have to repeat with 3 and so on until you reach the square root of the highest number in the table, because then we can stop. There are no more, because we have all tested all the divisibility for all, if we check up till square root 1000. So what here is a mostly declarative solution. So I haven't found a way yet to write completely declarative solution in SQL. So this is Oracle PL/SQL. What I do here is I determine the square root of the highest number, depending on if there's 100,000 or 1 million. And here actually are the steps that I outlined already. So we check for divisibility, and this is another optimization. I'm not sure if there's any gain by putting it here. We can ignore values smaller than the number we are checking squared, because all are smaller than that are primes already. And here we find the next one, number to test with. And here is, we have a procedural component, but this is a mostly declarative solution. What students usually come up with is something like that. So this is not contrived, it was actually submitted. And they use a cursor which as such is very slow, and they have nested loops, and use delete only, so the declarative part, SQL, only to delete single numbers from the table. And this is actually very slow. So I mentioned my solution takes about 10 seconds for 1 million. And I get homeworks where the students tell me, oh, I'm sorry, I couldn't provide the timing for 1 million because my laptop ran 2 hours and with the fan at full speed, and I had to stop it. So just one additional note. I haven't found a completely declarative solution in SQL, and I'm not dogmatic about that. If I have a procedural extension and it works well, why not use it? But what's important is to use as much declarative code as possible. SQL has recursion, and it is therefore Turing complete. So this, for instance, is would just generate a list of the numbers from 1 to 1 million. You can run it in SQLite. And actually, I used code like this to fill the initial primes table. And it's odd, but it's also a lot faster than if you make a loop in PLSQL and insert it with the loop, because obviously they have some optimization, and it's I didn't make timings for that, but it feels like 10 times faster. So to conclude, SQL, is it a declarative success story? I would say yes, because implementations are around since 1979. Oracle was one of the first companies to have a commercial SQL implementation. It's the query language for almost all RDBMS. It's an ISO standard. It's interesting, the first version of the standard had 120 pages. At the moment, SQL 2019 has 15 parts, and it's thousands of pages. And you need a lot of money if you want to have a look at it, because each part they charge between 100 and 200 Swiss francs. Not that it would be interesting to look into the standards documents, because the standard is ambiguous and contradictory. So there are some points misinterpreted, which makes the system, or which makes the feature unusable. For instance, the unique constraint in Microsoft SQL server would be such a point. It's about null. How many nulls do you allow in a unique column? Do you allow only one, or as many as you want? And they allow only one, which, if you think of that, is very stupid. For instance, if that column tells you whose spouse someone is, so if it should be unique, because you can be married only to one person. And in Oracle, if you only so when you're not married, then it would say null. And in SQL Server, they allow only one null. So only one person can be unmarried, all others have to be married. So this is a misinterpretation of the standard. And some even say it's contradictory. So if you would implement all of it, then the system would be unusable. So implementations of SQL are a superset of a subset of the standard. So it's treated more like a recommendation by the vendors. Why would we prefer declarative solutions in RDBMS? The query optimizers have evolved for decades, and they are doing the job very well. So you can trust the query optimizer, they are faster. Some RDBMS even don't have procedural extensions like SQLite, for instance. And declarative solutions are more portable. So there are always surprises involved. If you take your declarative solution on SQL Server and put it to Oracle, there are always some surprises. So, but it's more portable. If you take a procedural code, for instance, TSQL, and try to port it to PLSQL, there are a lot of there are many more changes involved, and it's probably it couldn't be done automatically. Declarative code is less error prone. So in SQL, unless you use recursion, you cannot create an infinite loop. And often you can directly translate from the problem description into SQL. Declarative solutions have a tendency to be shorter. Are they easier to read? I'm not sure. So it depends on if you are trained in writing or reading declaratively, then it might be easier, but it's another way of thinking. Do we need a programming facility? Well, I would say it is necessary. SQLite, for instance, doesn't have it. If you don't have it, you have for bigger pieces of software, you have it leads to code repetition. And you not necessarily would need procedural constructs, but it would be good to have a means to create user-defined functions. But the user-defined function can the body of it can be just one SQL statement. The same with table-valued functions, with which return a table, not a single value, and you can use it in the from clause like a view. But sometimes you need to parameterize the view, and if you don't have a means to do that, then it's awkward. So here maybe is a better explanation what declarative code means. The abstractions that remain after generalizable, error-prone expert knowledge is moved into a reusable black box component. If we look at SQL databases, what would be expert knowledge? For instance, the query optimizer. As a user, I'm not interested in execution plans or query rewrite or query caching or access paths or join methods or what sorting algorithm is used. It should be the problem of the system. And also things like memory management, like data caching or automatic indexing. Maybe, you know, if you create a primary key, then automatically an index is created, because otherwise checking if the key exists would be too slow. But as someone using the declarative language, I'm not interested in this kind of feature. And constraint checking or transaction management, I only want to say rollback when I want all the changes undone, and not how it is implemented and how it works. Or for instance, the concurrency control. When I planned this presentation, I was too ambitious. So I had to strip away a lot of what I meant to cover. And so it's in the title, the unused potential, which actually should say the unused potential of the relational database model. Chris Date, whom some of you may know, he is probably the person knowing best about the relational database model. Says no one has built relational database yet. So SQL databases are not a faithful implementation of the relational database model. And I didn't cover the important aspect of declarative constraints. Like every database is a logical system. And for instance, declarative constraints would be, well, data types are declarative constraints, simple declarative constraints, but we have foreign keys, primary keys, check constraints, and so on. But although it is in the standard, the vendors do not implement general user-defined table and database-wide constraints. So for instance, you cannot have a check constraint that checks some conditions which involve two or more tables, and you cannot even write constraints that check. So constraints are only in a row. You cannot write a constraint that is valid for a table, unless except the simple ones like unique and primary key constraint. Because the vendors just say, if you want that, write a trigger, and trigger is always procedural code. There is, Chris Date and Hugh Darwin suggested a better relational language, which they called tutorial D, which has all that set, so a real set behavior of relations, real user-defined data types, and general user-defined constraints. There is an implementation which is called REL, and maybe this would be a topic for another presentation. Here are some recommendations for literature. If you would like to have more insight into those topics. And finally, I would like to thank the organizers of this conference. It's a pleasure being here. And I also would like to thank the Erasmus Plus program of the European Union, because otherwise it would not be possible for me to come to conferences like this, because schools are notoriously short of money, and there would be no way to travel to conferences. Are there any questions? Okay, thank you. And here is my contact information, and I mentioned student internships. So if you're in a company and you might be interested, for instance, to take 2 of our students for 6 weeks in summer, please contact me. And if you have interesting projects for diploma thesis projects, I would be very happy if you would get in contact with me. Thank you.
Thank you very much, Günter.